Welcome to the lecture series of Basic Electrical Engineering. The subject code is ECE 101. The topic of today's video is series resonance of AC circuits. In this we talked about the series resonance and what do you mean by the series resonance and what do you mean by the series resonance frequency. The frequency at which the value of inductive reactance, which is known as XL, is equal to the capacitive reactance Xc, is known as resonance frequency, and this condition is known as resonance. The condition is XL is equals to Xc as shown here. So when we are having this condition, we will get the resonance condition. So we put the value of XL, as we know from the previous video lectures that XL is equals to omega L and XC is equals to 1 upon omega C, and the value of omega is equals to 2 pi F. So we put the value of XL and XC, it become omega L is equals to 1 upon omega C. Now omega square is equals to 1 upon LC, or omega is equals to 1 upon under root LC. We put the value of omega is equals to 2 pi F. So 2 pi F is equals to 1 upon under root LC, or F is equals to 1 upon 2 pi under root LC. This is called the resonance frequency. Now we find the effect of resonance frequency on series impedance. As we know, impedance is equals to Z is equals to R square plus XL minus XC square, the whole under root. This we find out in the previous lecture where we discussed RLC series response. Please refer that video. Now we said that XL is equals to XC, as this is the condition of resonance. So we put here XL is equals to, we replace XL with XC. So these two values cut down and we left with Z is equals to R square, the whole under root R square. This cut down and we will left with Z is equals to R. Z naught is equals to R. Naught means Z, when we put Z naught, it means that we are talking about the resonance value. So it is Z is equals to R at series resonance condition when XL is equals to XC. The second term is current. I is equals to V upon Z, and we put the find the resonant current. I naught is equals to V upon Z naught, and we find out that Z naught is equals to R. So V upon R is the resonant current. Then the third term is power factor cos phi. It is Z upon R. So we know the value of Z naught is R. So R upon R is equals to 1, and we can say that at resonant condition cos phi is equals to 1, called unity. So the resonant power factor at resonant frequency is unity, and cos phi is equals to cos inverse 1, and that is equals to 0. And the next term which we find out is active power. P is equals to VI cos phi. Power at resonant is P naught is equals to VI naught cos phi naught. So we put the value of I naught, which is V upon R, and cos phi naught is equals to 0. So we put these values, we get P naught is equals to V square upon R. Then reactive power, Q is equals to VI sin phi, and units are VAR. Q naught is reactive power at resonant. This is E. So q naught is equals to v I naught sine phi naught. This fine. We put the value of I naught, or we put the value of sine naught. Sine 0 is 0, so phi naught q naught is equals to 0. Then apparent power, that is S is equals to VI, V into I naught, or I naught is equals to V upon R, or it S naught is equals to V square upon R. So this is our apparent power. Apparent power's formula is this. So next topic is Q factor of series resonant circuit. What do you mean by the Q factor? It is basically the quality factor. In a series resonating circuit, Q factor, quality factor, is defined as the ratio of voltage across inductor VL, voltage across inductor is VL, or capacitor VC to the applied voltage. Means it is the ratio of VL upon VC, or the ratio of VC upon V. So we know VL is equals to the voltage in inductor, VC is the voltage in capacitor, and V is the applied voltage. When we talking about the inductor, Q is equals to VL upon V, and we know that VL is equals to I into XL, and V is equals to IR. So we put the values, I cut down, and we left with XL upon R. And we know the value of XL, it is omega naught L. So, and again we know the value of omega naught is equals to 1 upon under root LC, as we find out in the resonance. So put these values, then we find out Q is equals to 1 upon under root LC into L upon R. We can then we solve it, and we will get Q is equals to 1 by R under root L upon C. And this is the simple calculation which we do it for simplification. Then for the case of capacitance, Q is equals to VC upon V. We put the value of VC, that is I XC upon IR. I cut down, and we left with XC upon R. We put the value of XC, that is 1 upon omega C R, and we put the value of omega C, which is 1 upon under root LC, and finally we will get the answer, this 1 upon R under root L upon C. So this is for the capacitance, and this is for the inductance, and we talked about the quality factor. And if we discussed its definition, it is, in a series resonating circuit, quality factor is defined as ratio of voltage across the inductor or capacitor to the applied voltage. So in this lecture we discussed the resonant series resonance. What do you mean by this resonance? What do you mean by the resonant frequency? Then what do you mean by the quality factor? So this is all about your today's lecture. Hope you like this lecture. Thank you very much.